All right, lecture G8, daylight management. This one is about the daylight management basics and some daylight planning suggestions. The basics. What is light? That can be described as an electromagnetic wave. We all know that from our physics classes in school. It has a visible range from 350 to 750 nanometers, and the colors are actually defined by the different wavelengths. We do have two basics, luminous fluxes, which is actually the energy emitted by light sources versus the illuminance, the lux, which means it's what really hits the surface. So how is this to be described? The lumens is the energy given by a certain resource. It doesn't change, versus the illuminance, so what really hits the surface, what really reaches the surface, which is obviously depending on the distance, so the energy dividing by the distance to the surface. This illuminance intensity, the candela, which is a number which is normally given for, or a graph, a polar diagram, this free-form Kirby diagrams, which is given to light resources to identify the performance of the light resource as a result. This luminance intensity, luminance reflecting a surface, creates this luminance. The luminance is actually what we, as a result, on our surface get. So this white table getting a light source, by example, by a light bulb, then the reflection of the surface that really reaches us, what really reaches my eye, is called the illuminance. Then we need to define the light colors. Light colors you see on the left side, it's a warm white, less than 3300 Kelvin, the neutral white 300 to 5000 Kelvin, and then the bright daylight, the white daylight, which is 5300, which is actually quite bright as a color. We need to define the daylight quotient, which is the daylight quotient, which is a measure of the daylight supply for rooms and buildings. It's indicated of the ratio of illuminance, measured in lux, in the room to the illuminance at the outside on a cloudy sky, which is the daylight factor. So how much daylight do we get to our inside? Why is this important? Because we need to deal with it in our planning and our detailing. What are the factors influencing our daylight quality? The direction, obviously, it's surrounding, correlation of materials reflecting light, the type, size of windows, obvious. The position of the openings, the windows in the wall, also obvious. The structure of the room, the light distribution in the room, the type and quality of the light, sun protection, and the covers inside and outside. Why do we deal with that, or how do we need to organize this? Daylight defines by the geographical situation, which means it's a geographical optimization, orientation towards sun, and it's about the components, the type of glazing, selectivity, the reflection of the surface, sun protection system, and daylight system, if there's a daylight system, which we will see in a second. Daylight optimization, conflicts and dependency, also an interesting one. So what we actually want, we want the supply function, the top one in this line, but also need to make sure that there's no glare, so it needs to be shielded. We want to have a solar heating generation in winter, but we also want solar protection, sun protection against overheating in the summer. We want a daylight input, the energy saving to reduce the artificial light, versus thermal insulation against heat losses to the outside, or, for example, overheating, if this may happen. And then there's a clear interrelation between the daylight autonomy, so being able to get as much daylight as necessary into a room, versus electricity consumption. And that's what happens here, the daylight factor versus the power requirement. So the daylight autonomy on and off, which is the blue line up, versus the power required for artificial light on off, which is the red line down. So the more daylight autonomy I have, logic. The less electricity, less current I need to run the system. How do we deal with that? How do we engineer this? There's software which expresses to us the illumination settings for a certain room. So we see the shade situation, you see the shade moving around the building, you see the different times, you see actually the impact to rooms, daylight impact to these rooms depending on the size of the windows and their position to the building, and that also in horizontal section ends up, say, in the looks, the light intensity at the inside of these buildings, and you see close to the window. So, for example, this sample close to the window, there's a lot of light getting to the inside, versus at the far end of the room, or maybe the corridor, the inner part, there's a very limited amount of daylight reaching this surface. We can control this with daylight control systems. We have static, tracking, renewable, and switchable systems. There's a light scattering within the glass, or, for example, switchable systems, photochromic switchable glass. There's light deflection, prismatic plates in static systems, or rotating lamellas, which can go up and down, which is, say, the standard which we deal with. And there are light transport systems, so light pipes or heliostats, so actually reflectors, mirrors, which really bring the light into our buildings, which then serve as a natural light resource in the building, but rather complex in being designed. How do we use this in our buildings? A very nice project in Frankfurt, European Central Bank. I was in there, and you see directly, so there's no direct glare at the surface, depending to the situation. In a situation that there's direct glare, they would be able to have a shutter down at the inside to reduce that glare, but then obviously artificial light will be needed. The surfaces here, the inner surfaces, are designed so that there's enough reflection on the surface, or the light as well. 500 lux per square meter, something like this, at this inner surface, while in the inner part, in the corridor part, for example, there's no working space, so the illumination could be less, so it's allowed to have less light there. And then again, if it's too little, then you start using artificial light. This is this lecture G8 Daylight Management. It's part of the Delft Darmstadt Munich Facade Education project. Thanks.